Okay, to finish this particular proof, let's take a look at the given. It says that line segment AC is a perpendicular bisector of line segment BD. So if we take a look, that's been marked for us. Perpendicular bisector. Here it's cutting this segment BD in half so that BC is equal to CD. However, those congruent parts are really not of much use to us, given that we're trying to prove triangle ABE, which would be this triangle ABE congruent to triangle ADE. So these are the triangles that we're concerned with. Now hopefully you do see one thing, or hopefully you realize that to prove triangles congruent we need, in this case, 3 congruent statements, because this is not a right, these are not right triangles, at least the 2 that we're trying to prove congruent are, so we can't use hypotenuse leg. So we have to either use side, 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 angle, side, angle, side, angle, or angle, angle, side. So we need 3 congruent statements, and hopefully you see right here the reflexive property in that line segment AE is congruent to itself by the reflexive property. So that's congruent statement 1. That's a side congruent statement. We need 2 more of those. Okay, now we didn't use the given information to write that congruent statement, so we do need to use this given information. Now I know we said we couldn't use this part of it. However, there's a theorem. This is the definition. The theorem that bears this name, the perpendicular bisector theorem, says that any point on the perpendicular bisector is equidistant to the end point of the segment that's being cut in half. So for example, E is on the perpendicular bisector AC. So AB has to be congruent to AD by the perpendicular bisector theorem. Also, A is on the perpendicular bisector, so A to B has to be congruent to AD. So in this case, those are our final 2 statements. Both of them we were able to make because of the perpendicular bisector theorem. So let's get those down. We have line segment EB is congruent to line segment ED. And we have line segment AB is congruent to line segment AD. And again, the reason here is the perpendicular bisector theorem. Ditto. Side congruent statement, side congruent statement. Remember, the orders that we use here comes from the diagram, not here, but there's no confusing this because it's simply side, 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 so it's none of these. So triangle ABE is congruent to triangle ADE by the side, side, side congruence theorem. That's how you finish this particular proof.